1970s, our understanding of what's necessary for life itself was turned on its head with the discovery of hydrothermal vents. Deep on the seafloor, among huge pillars spilling superheated, chemical-rich fluid, scientists found life forms that don't require sunlight to exist, something previously thought to be impossible. Instead of sunlight and photosynthesis, the base of the food chain at these vent ecosystems was chemosynthesis, or the production of food using energy released by inorganic chemical reactions. But vents aren't the only ecosystems that can support chemosynthetic communities. Once scientists knew what to look for, they found them in hot springs on land, on the seafloor around whale carcasses and sunken ships, and in association with cold seeps around the world. Cold seeps are places where chemical-rich fluids and gases escape from fissures in the ocean floor. Unlike hydrothermal vents, which are fueled by geothermal activity, the seepage at these sites is fueled by immense pressure. Also, in contrast to vents, there isn't a strong increase in temperature relative to the surrounding waters. The chemicals that emerge from seeps are toxic to most forms of life. However, these chemicals, most importantly hydrogen sulfide, methane, and other hydrocarbons, actually provide the building blocks for entire chemosynthetic ecosystems. At the base of the food web are chemosynthetic microbes, some that live freely, and some of which live symbiotically within other organisms. Longer lasting and more stable than their vent counterparts, seeps can persist for decades, centuries, and likely even millennia before subsiding. But they don't last forever. Over time, the toxic flow lessens and stops entirely, and the ecosystem is settled by new species. From both a geological and ecological perspective, cold seeps are prime sites for new questions and answers, and then often more questions. Hello, everyone, and welcome to tonight's deep dive event offered through NOAA Ocean Exploration and the Ocean Exploration Cooperative Institute and supported by the National Marine Sanctuary Foundation. For today's program, I know we have registrants from far and wide, and if you haven't already done so, please say hello in the chat box and tell us where you're joining from. As you know, today our focus is on the rather mysterious and fascinating world of deep sea cold seeps. Cold seeps are places throughout the global ocean where chemicals like hydrogen sulfide, methane, and other hydrocarbon-rich fluids and gases escape from fissures in the ocean floor and support chemosynthetic communities. What you just saw was a short clip from our recently produced Deep Sea Dialogues video, which is a 10-minute piece in total that beautifully shares the basics of cold seeps through a dialogue with a cold seep expert. We hope you'll explore this on your own. The link is actually posted in tonight's event details for both YouTube and on Facebook. And it also will be shared in our resources for educator list as well. I'm Liz Hoadley, and tonight I'm excited to be joined by my colleague, Susan Haynes. Susan, come say hi.
Hi, everyone. So great to see you all tonight. So glad to see so many friends from American Samoa.
So just a little bit about our plan for the evening. So this is roughly a 90-minute event in total, and we'll spend about 45 to 50 minutes of that directly with our visiting cold seep expert, providing time for all of you to ask your great questions about cold seeps. And then we'll wrap up tonight's event by sharing a few of our fantastic cold seep education resources we have available on this topic to bring the topic alive in your classroom for students, as well as some information about our upcoming educator professional development opportunities, during which we go a little bit more in depth on recently developed lessons, fact sheets, videos, and more. For those of you that have joined us for previous virtual professional development workshops on deep sea coral, seamounts, hydrothermal vents, and more, first, thank you. This spring, we're doing things slightly differently, and rather than a multi-part professional development, we're now offering these professional learning and professional development options separately to allow for a little more flexibility with your schedules and give you the opportunity to spend even more time learning about the topic. This event, the Deep Dive into Cold Seeps, is a chance to learn more about the topic through a live Q&A with our expert and just an overview of those resources. Additionally, through our partnership with our Education Alliance partners around the country, we'll also be offering those professional development sessions. And again, that's a chance for us to dive deeper and actually demonstrate those lessons. So we'll share a little bit more about those and how to register for those at the end of tonight's event. And we hope you join us for more events this spring. So thank you for saying hi in the chat. As Susan mentioned, I see lots of people joining from American Samoa, which is very impressive, very different time zone. So I appreciate you guys making the time to join us. I see we've got some folks from the West Coast, all over, from California, Oregon. So great to see everyone. I'm joining in from Alabama. One of the things we love about this virtual environment is we can really join from far and wide. And I know we've got registered participants as far as American Samoa out west and Puerto Rico to our east. So really have a wide variety of folks joining us. And to get us started for our deep dive into cold seeps, we actually would like you to take part in a poll. So we have, using Mentimeter, a poll question for you to ask. If you've never used Mentimeter before, there's a couple ways for you to answer the question. The easiest would be if you've got a phone handy to open the camera and scan the QR code. Alternatively, you could type in www.menti.com and use the voting code pictured there. And if neither of those options work, the direct link to the question is actually posted in the event details. So regardless of what option, we want to know from our guests joining us tonight what your baseline knowledge is on cold seeps. And so our question is, relatively recently, cold seeps have been found to be much more common and prevalent than we knew in the early 2000s. And so cold seeps are known to exist in blank. Is it A, in every ocean basin, B, along the continental margins of every continent on the planet, C, at active and passive margins, or D, all of the above? And we'll give you a chance to answer. And while everyone is working out Menti and submitting their answers, I know we've got a little bit of a lag here. I wanted to share a little bit about ocean exploration in general. So our office, NOAA Ocean Exploration, was established in 2001 with a mission to explore the ocean for national and international benefit, focusing on the fact that our global future depends on our understanding of the ocean. Along with federally funded exploration opportunities on a number of NOAA vessels, NOAA Ocean Exploration operates the NOAA ship Okeanos Explorer. We at NOAA Ocean Exploration, along with many partners like Ocean Exploration Trust, who operates EV Nautilus, and Schmidt Ocean Institute, who operates RV Falkor 2, target areas that no one has ever been to before. And in many respects, we have no idea what we might find at these sites. Over the past several years, through seafloor mapping, water chemistry study, and expeditions with remotely operated vehicles, we've all been exploring unique cold seep ecosystems and communities, or the communities that call them home. For example, what you see on your screen now was a diverse community that was found in 2020. This image was actually taken at a cold seep site off the US West Coast and is showing a mass of snails called Neptunia and their egg masses, which are the yellow towers you see. If you look closely, you can even see that they're using clumps of tube worms as a place to anchor their egg masses, which would otherwise be in soft sediment. And so if you've ever watched any of our live feeds or videos from our ROV dives, you know there's always something new to learn when exploring the deep sea. And with that, let's take a look at those answers. Wow, we've got some cold seep experts in the room tonight. This will be awesome for our Q&A with our expert in just a moment. You are correct for those of you that answered D, which also means if you answered B or C, you're at least partially correct. So cold seeps are in fact found in all of the above places. So in every ocean basin, along the continental margins of every continent, and in active and passive margins. And so before I bring on tonight's expert, I'd also love to know a little bit about who we have joining us. And so I'd love for you guys to type in the chat. I want to know what you teach. And do you currently teach about cold seeps? And if you don't yet, what are you excited to learn tonight and share? So we'll get that question up. And again, if you can use the chat feature either on YouTube or Facebook, wherever you're joining us from, what is it that you're teaching? And do you currently teach about cold seeps? Or are you planning to incorporate them in your future curriculum? Let's see those answers rolling in. I saw earlier, I know we've got some science coaches on here, so very excited to have you share those with all of your teachers in your schools. I know we've got some lesson writers on here, so definitely want to see some more cold seeps incorporated out there. I'm very curious to know who's already teaching about cold seeps, and if not, what are you ready to learn? So Rick Reynolds is joining us. So he's K-12 Science, Social Studies, and Technology. And don't teach about cold seeps, but I love that you kept the possibility open, Rick, with a yet in there. So hopefully after tonight, we can change your mind. We got Sherry joining us for 6th and 8th grade science, and we do have some middle school resources to highlight a little bit tonight, but more importantly, in more depth, I should say, during our professional development later this spring. Love to see those incorporated. And with that, I keep them rolling in, but I will go ahead and introduce our guest expert because I'm so excited to have with us tonight, Melissa Betters. So Melissa is a PhD candidate at Temple University. And prior to starting her doctoral studies, she earned a bachelor's degree in biological sciences from Florida State University. She's participated in a number of different marine research projects during her studies, most recently including a survey of deep sea coral in the Papahānaumokuākea Marine National Monument in Hawaii. Broadly speaking, she's interested in the processes that generate and maintain deep sea biodiversity, and is particularly interested in the evolutionary origins of species at chemosynthetic ecosystems, like methane seeps. And so with a background in hydrocarbon seeps, her research is exploring the evolutionary history and possible links between species that thrive in chemosynthetic ecosystems and those that live in non-chemosynthetic and shallow water habitats. So all of this makes Melissa the perfect person to answer all the questions you might have tonight during our deep dive with an expert. Melissa, thank you for joining us.
Thank you for having me. I'm very excited to see everybody who's here, and I'm excited to answer all of your burning questions.
Yes, and it looks like we have so many biology teachers in the room, so I think we're going to get some good questions. And with that, it is time for all of our educators that are joining us on Facebook and YouTube to type any question you have for Melissa in the chat. So we will get to as many as we can. We've got about 45 to 50 minutes to work through those, so you do not need to be limited to one. Ask away. And while those start rolling in, Melissa, I think it'd be great to get to know our guest expert a little bit better. And first of all, cold seeps are so unique. How did you get into this? What captivated you or led you to this line of work?
Yeah, so I didn't always want to be a marine biologist. It was not love at first sight. You can see whenever my parents, well, these are my grandparents here, but when I was taken to the beach as a kid, it was sort of against my will. I'm the miserable one in pink here. But over time, I grew to love it. I am from Wisconsin originally, and so I didn't have a lot of experience with being near the ocean, unfortunately. And so I really grew to love it over time. And during my undergraduate degree, I really realized that the aspect of the ocean that really captivated me the most was the deep sea, and all of the questions that we still have yet to answer regarding the deep ocean. And that led me to cold seeps and the unique ecosystems that live there.
That's awesome. And I love that you were able to find a love for the ocean, even starting so far from the coast. That's exciting. We've got a couple questions rolling in, but I've got one more for you. And I'm actually would ask our media team behind the scenes if we can play a clip from the Deep Sea Dialogues again.
Cold seeps are found all around the world, in every ocean. They're found along continental margins. One place you can find them is at subduction zones, where one plate is sliding underneath another plate. When that happens, that underlying plate is undergoing a massive amount of pressure. Just like a sponge, all of the fluids and things contained in the sediment of that plate get expelled into the water column, and that's where we get seeps.
So that was just a really brief overview, correct, of where cold seeps are found. Since that was our kickoff question, I'm hoping that we can get things started, and maybe you can elaborate on that a little more and tell us, where do we find cold seeps and why?
Yeah, so cold seeps may be really unfamiliar to a lot of us, but they're incredibly common. The reason why they may be unfamiliar is just because of where they exist, right? They exist off the coast of continents. They are usually pretty deep, usually between 200 up to 5,000 or more meters below the surface of the ocean. So pretty deep down. And yeah, so they really are quite common. They occur. We found them in every ocean. And usually what happens is where these cold seeps occur is you'll have entire fields of cold seeps that occur. So it's not just, a single kind of anomalous thing that you find at the bottom of the ocean. They're as prevalent and as important a part of our oceans as, forests on land.
Awesome. Thank you. And I know I see some questions rolling in. And a big question for us often is we hear cold seeps described so often in the same sentence or context as hydrothermal vents. And since we've already done events on hydrothermal vents, I would love it. Like, can you help us differentiate the two? So why are hydrothermal vents, or how are they different than cold seeps?
Yeah, so that's a really important and a really good question. So hydrothermal vents, if you know what those are, you're about 90% of the way there of understanding what a cold seep is. So hydrothermal vents are going to be areas along the ocean floor that has geothermal activity. So typically what you have is underlying magma that is superheating the fluid that exists in the sediment of the ocean floor. And when that fluid gets superheated, it's actually expelled, and that's where you get hydrothermal vents. And so you can see examples of those in the videos here. You can see the shrimp that often exist, right around those point sources of fluid. And so hydrothermal vents are usually distinguished by really, really high temperatures. That's the biggest difference. Really, really high temperatures, very high heavy metal concentrations. So they're very toxic environments. Hydrocarbon or cold seeps. So cold seeps are a little bit different. The term cold is purely in reference to the surrounding seawater. So because these occur at the bottom of the ocean, the water is really just very slightly above freezing. It's very, very cold. And so you don't get that same geothermal activity here at cold seeps that you get at hydrothermal vents. You also don't typically see as high of concentrations of heavy metals at cold seeps. But what you do see is the expulsion of hydrocarbons. So that's things like natural gas that actually comes out of the water. And that's usually the bubbles that you're seeing. And then also an important thing to note is the similarities between hydrothermal vents and cold seeps. They're both considered chemosynthetic ecosystems. And so chemosynthesis is essentially the analog to photosynthesis. So photosynthesis is the process by which, for instance, plants on land take sunlight and convert it into energy. Chemosynthesis is taking chemicals and converting them into energy. And so both hydrothermal vents and cold seeps are driven by chemosynthetic bacteria and archaea that perform that chemosynthesis. They form the base of the food chain in both of these ecosystems. And so while they have those really stark environmental differences, they do have that really important similarity in common.
I love that you already brought up chemosynthesis too, because that's one of the great resources we'll be sharing later. I know we've just finished a fact sheet on it, and you were a huge help with that, by the way, so thank you.
Oh, thank you. Yeah, sorry if I'm throwing everybody into the deep end here.
No,
Ask me as many questions to clarify.
Yes, absolutely. On that note, we've got a couple more questions coming in, and I know we've got some good teachers here, so I'm really hoping we get a few more questions, or even questions your students might have. It's a really great one or opportunity to ask Melissa as well. So we've got one coming in the chat from Rick. He wants to know, Melissa, what's the coolest thing you've ever observed at a cold seep?
It's a good question. I think one of the coolest things that we've observed is, so this is a relatively recent discovery that is going to actually be further investigated later this year. But at one of the dives at the Costa Rica margin, actually, we found what we call the octopus's garden, which was just a whole field of brooding octopus that were situated over these, these outflows of fluid. And they all were brooding their eggs over the fluid coming up. And we really don't have any idea why. We don't know how they're using the fluids, what benefit they get. But it was pretty incredible to see just a field of, just octopuses just all laying around near each other. So it was pretty amazing. So research is being done actively on that to kind of figure out what was going on there. But honestly, anytime you get a chance to see a cold seep, they all have unique features to them. They all are kind of different and beautiful in their own ways. So any footage that we see of a cold seep is some of the first footage that we're ever seeing of cold seeps. We live in a time where, technology is allowing us access to these ecosystems. And so honestly, just the fact that we can see them at all is incredible.
I love that you brought that up too, because I know one of the things that Susan's going to share later is how anyone can follow along with our dives too. So not only is it incredible that we have the tools and technology to get down to observe these environments, we also have the tools and technology to bring it to people's screens at home. So you might not be in the sub, but you get to at least tune in and join with us. That's really special. All right, we've got a few more questions coming in, Melissa. So Summer wants to know, how are the organisms surrounding those hydrothermal vents the same and or different from those of the cold seep, since we know that they're both chemosynthetic? What do the communities look like there?
Yeah, so this is a great question to bring up more of the similarities. And so, like I said, both hydrothermal vents and cold seeps rely on chemosynthesis. And that is usually performed by the bacteria and the archaea at those sites. And what they tend to use is hydrogen sulfide. That's the compound that they need to survive at both of these sites. And so what you typically will find are what we call foundational species. And so those are going to be, in this case, the animals that form sort of the base of the ecosystem. So think of the trees of a forest, for instance, right? They provide the kind of the structure on which everything else lives. And so at both hydrothermal vents and cold seeps, you're going to find mussels as well as tube worms. So this is an example of a tube worm aggregation here, what we call a tube worm bush. And then also mussel beds. So really huge swaths of mussels all living very close together. You tend to find both of those near both hydrothermal vents and cold seeps. The main difference is they're going to be different species typically. And they're going to have slightly different biology. But for the most part, they're going to look somewhat similar. The biggest difference is honestly the fact that the hydrothermal vents have those really spectacular spires, big towers that kind of precipitate as the fluid comes up. Cold seeps don't have that. The 3D structure on which everything lives are the animals themselves. And so from there, at cold seeps, you'll have all of the kind of usual suspects. You'll have the crustaceans, you'll have shrimp, you'll have fishes of various species of fish. You'll have snails grazing, and those are actually the organisms that I study. I study the snails at cold seeps.
That's awesome. And I love that you talked about these kind of phases of organisms showing up. I know that's one of the connections we like to make for our life science teachers that are joining us. When we talk about ecological succession, a lot of times our classroom examples are terrestrial, they're forests, like you mentioned. And cold seeps are a really cool opportunity to not just bring the ocean in, but to specifically bring the deep sea. So some of our resources, I see we've got, I think we have a photo of it to preview and share with everybody. Really talks about this ecological succession. So hoping to have our educators check that out in a little bit as well. Awesome. All right, well, I think we need to wake up some of these teachers a little bit. And so we've got some mystery items to poll everybody as well. So I hope our educators on Facebook and YouTube are ready. But speaking of cold seeps, we've got some really cool observations that have been made at cold seeps, and some of which have stumped scientists in the past. And so let's see if we can get one of those mystery items up on the screen. So for all of our teachers who are joining, what do you think is pictured in this image? So this was taken on a cold seep. That is the only hint I will give you. And what is it that we are looking at? Here's another photo of the same thing, different photo, but in this case, that object is between two layers of sediment. By the way, if you are joining for or on YouTube and you don't see the option to type in an answer, you might have to log in. So I forgot to mention that earlier and apologize. But we've got some guesses rolling in. We've got microbial mat. Good guess. Similar appearance a lot of the time, not always white, but most of the time. But it is not a microbial mat. I'll give another hint. It is not living. Give it a few more seconds. Oh, we've got another microbial mat guess. Really good guesses. We do have some amazing footage of microbial mats to share too. See if we can get one more guess in there. Oh, I think we've got the closest one. Rick says ice. Melissa, can you tell us a little bit more about what our mystery item is?
Yes. So, Rick got it. It is ice, and it's not water. So this is actually, this is methane ice. So under certain conditions, particularly under very cold temperatures and really high pressures, like what you often get at cold seeps, you will have the formation of methane ice, which is what you see here. And so methane ice typically occurs deep down in the sediment. You don't often get to see it. But if the conditions are right and the tectonic activity has kind of pushed the underlying sediment up, or the soil has eroded away due to either ocean currents or what have you, then you can actually see the methane ice that forms at these environments. Yeah, a really spectacular example that you can see here. And so, good job, Rick. You got it.
That's awesome. And we had some good guesses come in with methane too. So put them together and you guys got it. And again, we've got some really cool resources to talk about that as well. This is one of them. This is actually taken off one of our ocean facts. So the methane model that we're all used to from our good ball and stick models. But a methane hydrate really has that. It's protected in this crystal shape or clathrate of water molecules. So that's what the middle image shows. So thanks, Melissa, for telling us about that. And good job, everyone. I think that's the harder one. We've got a little bit of an easier mystery item later. All right, we've got some more questions that have come in the meantime. I think we've sparked the chemistry teachers as well as some more life science. So if you're ready, Melissa, we've got from Maureen wants to know, or she first says, thank you for mentioning photosynthesis and chemosynthesis. And wants to know, can you please provide more details about chemosynthesis? Specifically, does it also have the Calvin cycle, but not have light-dependent stage as photosynthesis? Really wanting to know a little bit more about the mechanics that those microbes are doing.
Yeah, so the good thing is that NOAA has put together a lot of really great educational resources that really delves into the chemistry of this. So I know, Liz, you're going to talk a little bit about those resources in a bit. But I would really recommend diving into that. As far as whether chemosynthesis also has the Kelvin cycle? I believe it does, but I'm going to be honest, I am not a chemist. I am firmly in biology, and I study some higher organisms, but I do believe that the Kelvin cycle does also occur, like you said, without the light-dependent stages, without the photosystems. They use a different electron acceptor at the end of the cycle, but I don't know the specifics. I'm so sorry.
No, it's okay. And like you said, we do have some great resources, and I think it's always great to hear from the experts about it is a complex process. I know
Yeah.
we really took a lot of our time trying to get it simplified and pared down because it is quite complex. So it was really neat to learn about those different electron receptors and the opportunity to kind of bring that into for students as well. All right, we've got some more questions coming in. Oh, going back to our methane ice for a second. What temperature do you think it might be for that to freeze? Like, what are those conditions?
Yeah, so the temperature would have to be at least cold enough for the water that surrounds the methane molecule to freeze. So that is typically why you actually see these conditions or these hydrates form a little bit lower underneath the surface, underneath the sediment. And so it's not unusual to have the temperatures of the water at these cold seeps pretty much be at or just above freezing, allowing for the formation of this ice. The main reason why it doesn't freeze is because, you know, they're so deep down that the pressure of the overlying water actually prevents the seawater from freezing, as well as the salinity. And so, yeah, it's exactly the same sort of freezing process as water, but that is going to happen pretty deep in the ocean.
Awesome. All right, I think we've talked a little bit or a lot of it about this point about the biological diversity that we find at cold seeps. And so I don't think what we've covered yet is the geological diversity or the different formations, right? So unlike vents, like you mentioned, that have that classic chimney, are all cold seeps, do they look the same above the sediment? If not, what are scientists looking for when they go looking for cold seeps?
Yeah, so I'll answer this question in a few parts. So first, how do we actually find cold seeps? One of the ways that we identify cold seeps is using sonar. So we can actually see the bubble plumes that come up out of the sediment that can be indicative of seepage happening at these sites. And so if we have captured these bubble plumes on sonar, scientists have a pretty good inclination that if we were to dive there, we would see something pretty interesting. And so that's one thing that tends to be common across all cold seeps. But cold seeps really are, as mentioned at the beginning of the video, cold seeps are formed through subduction. So as that underlying plate slides underneath the overlying plate, both experience massive amounts of pressure, and it essentially squeezes out all of the fluids and all of the chemicals that are in the sediment of those plates out and into the water column. And so that can take many forms. Most cold seeps, you're going to have a high concentration of hydrocarbons from the breakdown of organic material over time. But you'll also get, for instance, salt seeps, and that is where you get brine pools, for instance. And so brine pools is where you have extremely salty water escaping from the underlying sediment. And it's actually so salty that it can't mix with the overlying water at all. And it forms these really beautiful pools. And because it's a cold seep, just like every other seep, it will still have that hydrogen sulfide needed to proceed with chemosynthesis. And so you still have that, yeah. So what you're seeing in that video was actually a camera being put into the hypersaline water at a brine pool. Pretty incredible. You'll also get formations, for instance, right, the methane hydrate that we saw. You'll also have things like tar lilies where you'll have, essentially tar coming up from the bottom of the ocean and forming these really incredible formations. So anything that is in that underlying plate, as well as the overlying plate, can and will get squeezed out into the overlying water and form a seep. It's pretty amazing.
Yeah, and I know when we first started talking to you about this subject and you were kind of giving us some of these analogies to help us make sense of this topic, I think one that really resonated with our team was your sponge analogy. And just this idea of squeezing a sponge and everything that's in it getting pushed out, whether that is thick like tar or bubbles like methane or hydrogen sulfide. So that I know that's a really cool one and a low budget one too, so that we can get into our teachers' classrooms as well.
Yeah, exactly. That would be a great demonstration.
Yeah. And kind of thinking of other things that students might like to learn about cold seeps, I think animals are always a hit. And one we had come in earlier this week that I wanted a chance to ask to share with our teachers tonight, Yeti crabs. Yeti crabs I've seen a lot on Facebook recently, but specific to hydrothermal vents. Is that one of those animals that we could find in both environments?
Yes, so exactly. Yeti crabs do also occur at cold seeps. So we got to see really awesome aggregations of Yeti crabs. This is the species Kiwa puravida, which is the Costa Rican Yeti crab. So this is an aggregation we saw at the Costa Rica margin cold seeps that I study. So if you don't know about Yeti crabs, obviously, they're named for their extremely hairy arms. And what they use those for is they're actually bristles off of their carapace. And what they do is they farm chemosynthetic bacteria on all of the bristles on their arms. And so they wave their arms in the little Yeti crab dance over the point sources of fluid, and it feeds the bacteria that they're trying to farm. And then they essentially farm their own food that way. That is a group of organisms that occurs both at hydrothermal vents as well as cold seeps. And I love them.
I do too. And it looks like we have some of our people on the line too, because lots and lots of comments coming in with love for those Yeti crabs. And also it's a great jump off point so you talk about them farming these microbes. That's an example of symbiosis, right?
Yeah. So symbiosis is a really important concept and actually a great way to incorporate cold seeps into curricula. So symbiosis, as educators I'm sure know, but symbiosis is a beneficial, or actually it's just any close association between two organisms. And so what you see at cold seeps are mutualisms. So those foundational species that I mentioned before, the mussels and the tube worms that kind of form the 3D structure on which everything else lives, they have a symbiotic relationship with chemosynthetic bacteria. So both tube worms as well as mussels have chemosynthetic bacteria that lives in their gill structures and actually performs chemosynthesis and allows them to access the nutrients from the system. And so that is one of the reasons why they are the foundational species, is because they rely on these bacteria in order to live. And so once seepage actually begins at these sites, those foundational species are going to be the first things that get there because they can't live anywhere else, because they rely on their symbiotic bacteria to actually live.
That's awesome. So we've kind of got microbes, our foundation species like tube worms and mussels, and then it just transitions right into Nicole's question. So Nicole wanted to know, what is the biodiversity like at a seep? So beyond those foundational species, what is the biodiversity like?
Yeah. So one of the great things about cold seeps is that they are biodiversity hotspots on the ocean floor. Because if you think about most of the ocean, it's going to be bare sediment. It's going to be layers and layers of mush. Not a lot of places to live. not a lot of energy to access. So in most parts of the ocean, you are completely reliant on energy that floats down from the surface. So for instance, any organism or photosynthetic algae that uses the sun for its energy, that will eventually die and sink down to the bottom of the ocean. And for most of the ocean floor, that is your main source of energy. But at both cold seeps and hydrothermal vents, they have this secondary, access to all of this chemical energy. And so, yeah, they are biodiversity hotspots. At cold seeps, you'll have, when seepage is really going strong, you'll have the foundational taxa. You'll also have any number of crab species, brittle stars, starfish. Further away from the seeps, you'll also have corals as well as sponges living on the hard substrate left behind by perhaps foundational species that lived too far away as the gases move around. But yeah, you have pretty much everything that lives there, that can live there. You have fish that come down and prey on all of the little invertebrates that live at these sites. So they're quite a tapestry of organisms. And yeah, we're still trying to understand that diversity, to document that diversity. There's still a lot that we haven't discovered yet, and a ton of new species that have yet to be discovered.
Yeah, and I'm so glad you kind of really danced around the biodiversity, but also some of the different species there and the fact that these sites are so rich for new discovery. Can you tell us a little bit about your research and how that fits into this topic?
Yeah, so like I said, my research is on cold seep snails. So I look at the tiny little snails that live on mussel shells as well as tube worms. And they are the primary grazers at these sites. So in addition to chemosynthetic bacteria living in the gills of the foundational species, you also have bacteria that coats pretty much every hard surface. And so the snails that I study, of which you can see a bunch of them in this video, they're super small. They actually graze on the bacteria that lives on these hard substrates. And so my research looks to answer questions regarding what processes generate biodiversity in the deep ocean. Where do species come from? What's the connection between hydrothermal vents and cold seeps? What's the global connection? So, we're trying to I'm trying to understand, just how isolated or connected these ecosystems are to each other. Because once we kind of understand that, we get a better sense of how resilient they are to disturbance and to change. Because if everything occurs in isolation, that makes them very vulnerable. But if things are really widely connected, that affords us a bit more protection. And so it's a really interesting and really important trying to answer with my research.
That's so awesome. And I did not realize how tiny they were when we saw that first close-up image. It was really cool to see them zoomed out in that footage.
They're so tiny. So in that first image, the scale bar that's behind them are millimeters. So they're extremely small.
Wow.
Most of them are less than a centimeter in length.
That's awesome. So cool.
Mm-hmm.
And yeah, I think it's also just a great topic for students too, of like, you really can study anything. There's so much to be studied in the deep sea.
Yeah.
So kind of thinking about our audience here being middle school and high school teachers, I'm so glad that Isabel brought up kind of driving that message home. And I'm certain this is a question students would ask them. Are cold seeps important, and why? Why should we care about cold seeps?
Yeah, that is a really important question to ask. And the answer is, of course, they're important, right? I'm of course going to say that. That's what I study. But no, really, they are incredibly important ecosystems. So like I said, these are areas where hydrocarbons, natural gas is getting pushed out of the sediment. And we've seen those videos, right, during this program of those bubbles rising. And those are going somewhere. They're going towards the surface of the ocean, and they're going towards our atmosphere. And right, those are essentially greenhouse gases. And so when you have, bare hydrocarbon cold seeps like these that you see here with no living things on them, those hydrocarbons are going to just make their way to the surface, and that'll be that. But at Cold Seeps, you have these entire aggregations of animals that capture that natural gas and actually sequester it on the bottom of the ocean. And so there is another chemical process that occurs here. So in addition to the metabolism of hydrogen sulfide, you also have the oxidation of methane. So the main component in natural gas. And so the anaerobic oxidation of methane is a hugely important process. And those consortia of microbes that perform that process live at these cold seeps and sequester something like 90% of all of the natural gas released at the ocean floor. So these are hugely, important ecosystems for the health of not only our oceans, but also for our entire planet.
That's incredible. 90% of those hydrocarbons. Wow. And
upwards of 90% by some estimates. Yeah.
Wow. Yeah, our teachers are enjoying this too. So really, really great topic to drive home for another deep sea topic that should be in the classroom. Students should be learning about this. That's exciting. Well, I know I could ask questions all night, but do want to give a reminder, a chance to our teachers. We've got about 15 to 20 more minutes here with Melissa. So if you've got those questions, please do feel free to drop them in the chat for her to answer before we have to say goodnight. And while those come in, we've got one more in our queue from Summer. So kind of going back to the geology for a second. So do cold seeps occur at specific seafloor features or tectonic plate boundaries? And kind of how do they form? So I think too with the where, you described that sponge analogy really well, but we've got people joining from all over, and I'm sure they want to know about cold seeps in their backyard.
Yeah. So cold seeps occur along, like we've said, along pretty much every tectonic margin. So I study cold seeps at Costa Rica. There's also cold seeps to be found off the Oregon coast and off of the west coast of the US. I know there are cold seeps that occur in the South China Sea and really all over the place. If you're wondering, I know I saw at least one question wondering if we have cold seeps, near us. The answer is most likely yes. Whether they've been discovered or not is another question. But if you have a plate subducting anywhere near where you live, like the west coast of the U.S., or the western Pacific margins, you will most likely have these cold seep ecosystems near you. Usually, in addition to hydrothermal vents that will also be nearby. So particularly, the Western Pacific is going to be particularly near Fiji and off of Japan are extremely active tectonic areas. And so I know for sure that there's going to be some cold seeps out there that definitely warrant more exploration.
I love that. Absolutely. And I know that Okeanos is heading out that way next year. We've got EV Nautilus is heading out to the Pacific as well. So I see some future cold seep footage coming our way soon.
Oh, yeah.
Actually, that's one I kind of want to jump into next. You mentioned that there's some research going back to that octopus garden. Can you tell us a little bit about what that expedition is and maybe how some of our teachers could follow along?
Yeah, so that is going to be, an ocean exploration cruise. I believe it's on the Falcor 2. Does that sound right, Liz?
I believe so, yeah. And I think it's this early summer. So for teachers who are still in, and all 3 of those ships live stream anytime the ROV is down in the water. So right now, Falcor 2 is actually out on the Mid-Atlantic Ridge, which I believe is one of the only places where there aren't cold seeps. So no footage coming up there, but some cool hydrothermal vents that they're searching or researching. But definitely keep your eyes posted or keep your eyes peeled. And I know Susan's going to share one of the websites later that makes it easy to track where all 3 ships are currently and where they're heading next.
So, and I would definitely recommend doing that. The footage that I saw of that is just incredible. It will be worth the wait. And yeah, I believe that cruise is happening in June. So keep an eye out for that.
I was going to say, that sounds right. Awesome. And I know we've got our team in the background also sharing some resources about octopus odysseys. That sound familiar? And for our teachers joining from California, wasn't there also another octopus garden found off the coast of Monterey?
I believe so. Yeah, I believe so. I think that's where that really famous footage of that googly-eyed Dumbo octopus came from as well.
That's right. Absolutely. And I think that resource was shared in the chat just a little while ago too. Awesome. And I see Rick tuning in and saying yes. Thanks, Rick. Awesome. Well, I know we've got a few more questions if you're game for it. So I think you told us about the coolest thing you've ever seen, but I'm wondering, is that the coolest field experience you've ever had in the deep sea? And if not, can you tell us just a little bit about what it's like to be an ocean explorer and what's the coolest part about it?
Yeah, so probably the coolest experience I have in the deep sea actually doesn't have to do with cold seeps. But it's because I was able to actually go to the bottom of the ocean in the Papahanaumokuakea National Monument in 2017. That's me on top of the Pisces 5. So the Pisces 5 and the Pisces 4 were both human-operated vehicles. So I actually got to go down into a submarine and get to go to the bottom of the ocean and explore some of the seamounts off of the coast of Hawaii. And so that's us. That's our selfie at 1,000 meters, which I was pretty happy about with our amazing sub-pilot, Terry Kirby. And so, yeah, that was probably just, I mean, it was like landing on another planet. It's an experience that is unlike anything else. And yeah, that's my sort of my all-time favorite experience was actually getting to go to these ecosystems that I love so much and that you usually only get to see, through really amazing videos, but seeing it with your own eyes is something really spectacular. Yeah.
That's amazing. And yeah, Isabel's commenting, fun, I bet. And I definitely want to go down into sub, but can you tell us a little bit? What's it like? They're not super spacious, are they?
Yeah, no. So that selfie that you saw was about as much room as there is in the submarine. You are in essentially a tiny little sphere that fits 3 people. You go down for 8 hours. There's no bathroom.
Wow.
You pack your lunch, you pack a sweater, because as you actually go down into the depths of the ocean, you don't really think about it, but the temperature drops pretty quickly. And so when you're starting at the surface near Hawaii, it's going to be really tropical, very lovely and sunny. It gets cold very, very quickly. And so, yeah, you see the sunlight disappear, you put on all your sweaters, you turn on the sublights, and yeah, it's a pretty amazing experience seeing what kind of floats into view. For instance, in my first dive, we landed on the bottom and immediately a 6-gill shark came and said hi to our sub. So I was face to face with a huge 6-gill shark, and that was my sort of welcome to the bottom of the ocean.
That's really hard to top for sure.
Yeah.
So I think one of the things that we love to bring up too that is sometimes hard to capture, because we hear these exciting stories like going down in the Pisces or being out at sea. But what's it like as an ocean explorer? Like, is that a majority of your work, or what is that balance between field work, lab work? Like, what's your day-to-day look like?
Yeah. So Unfortunately, that is not going to be part of your daily job description. But that doesn't mean that your work is any less exciting. Most of my day is going to be spent. So most of the time, these research expeditions are, really gold mines. Once you get the opportunity to go out to the bottom of the ocean, you get all that you can. You get the footage, you get the water measurements, you get animal collections, and it's not uncommon for scientists to literally spend the next 10 years analyzing what they found, 5, 10 years, because it's so rare, right? These ecosystems are so far away, so difficult to access that we really don't take anything for granted. And anything that we do take from these environments, we do use to the best of our ability to answer those really important scientific questions. And so most of the time, you're working through the data, you're looking at the collections that you've got. And even though it's not going down to the bottom of the ocean, you're still working to answer questions that, I'm really passionate about, and learning new things every day that humans haven't had the opportunity to learn before. And so it really is pretty incredible. Even the day-to-day kind of minutia of life, it really keeps you going.
I love that. And I think just like you said, the fact that we are able to take so many measurements during even just a short cruise or expedition, it also means it's a great field for students to get involved in, right? There's a lot of projects for students to work on to analyze those samples.
Yeah, absolutely. So every branch of natural science has a place in the deep sea. Whether you are interested in geology or chemistry or plate tectonics, even paleontology, there is work to be done in the deep ocean, regardless of what question you want to ask, because there are just so many questions that still need to be asked and still need to be addressed. And so it's a really exciting time to be interested in the deep ocean, that's for sure.
That's a really, really, really good segue. And we're starting to wind down the evening. So if anyone has a last minute question to get in, now is your time. But I love that you're talking about how we can bring in any subject. And it's really a great, like the deep sea in general is a great topic for any science. That I know you're close to wrapping up your PhD. Do you have any advice for those middle school, high school students who are just like, that looks so cool when they see that deep sea footage?
Yeah. So, yeah, so my dad always gave me a piece of advice that I feel like I repeat all the time, but it really is to just make yourself ready for when opportunities come your way. You can't prepare for opportunities to come your way. You don't know when they will happen. You can just trust that they will happen. And when they do, be ready to say yes. So for instance, when I got to dive at the bottom of the ocean, that was not really planned. One of my professors in my university heard that I was interested in deep sea biology and on a whim asked if I wanted to go on this research cruise. And I was ready and willing to say yes to that opportunity. And I knew enough to know kind of what I was getting into, and I knew enough that I needed to say yes. And so, right, nothing would have been worse if I wasn't prepared to take that opportunity. And so that's what I would say as my piece of advice to anybody who's interested in pursuing a dream of yours, regardless of whether it has to do with the deep sea or not. But make yourself as ready as possible to say yes when opportunities occur. And all you can do is prepare for when those opportunities will come your way.
That's really powerful. That's awesome. Well, with that, I know as you're wrapping things up too with your PhD, I know it's faux pas to say what's next, but what are you excited about in this field that you see coming down the pike that you can be a part of? Or what's exciting about Cold Seeps kind of going into the future? Where's the research direction going?
Yeah, so yeah, I'm aiming to finish my PhD this year. And so I really hope to continue working on some of the questions that I've been asking. I've particularly been studying the Pacific Ocean and kind of the patterns of speciation that we see there. But mainly, I really think that one of the things that's so exciting is all of the new species that we just keep discovering in the deep ocean. I just love to see them. It's really not a hyperbole to say that I think there's a new species described almost every month from the deep ocean. And so seeing all of these new animals that are new to science and new to us, and continuing to see those discoveries being made is just, it's something that I'm, so excited about. And yeah, even having access to the live streams that NOAA facilitates. I know I've been tracking, me and all of my colleagues have been tracking the mid-Atlantic rise dives that are happening right now. And it's just been incredible to find whole ecosystems that we haven't, discovered yet. And so regardless of what comes next for me, I am an avid deep sea, fan as well as an expert, but a fan first. And so, I'm really excited to just see what comes next.
I love that. And as those new species are discovered, I hope to see one of those snails with your name attached to the end of it. I know we just had one of our bench experts, Dr. Pete Gerges, have a Yeti crab named after him. So I can't think of a cooler honor as a Yeti crab named after you, but the snails would be a cool follow-up.
Yeah, that would be awesome.
Well, we've got a million thanks coming in the chat. And yes, Melissa, thank you so much for your time, not just tonight, but also helping develop all those resources that Susan's going to share shortly. And we really do appreciate you sharing all your firsthand experience and knowledge in the field and advice for students. It's been a pleasure having you this evening.
Yeah,
it's been a you pleasure. Can see those comments rolling in.
Thank you. Yeah, no, it's been really great to answer your questions and to see what you've been curious about. And I hope you leave today with a bit more of an understanding about cold seeps and their importance and diversity along the ocean floor. So thank you for having me.
Of course. And to all of our participants joining, if a really good question strikes you later, we'll be sure to share our email at the end and we will get that out to our experts. Always, we don't want to see those questions go unanswered because we want you to bring this into your classroom. So love to see the word of cold seeps getting out. But have a good evening, Melissa, and thank you again. And with that, we are just ready to turn the show over to Susan. So as you guys heard from that interview, marine seeps are fascinating, not because of their history or formation or processes, but really all of it. And the fact that they're this foundation for such incredible deep sea communities that we really are just beginning to understand. So exciting to have researchers like Melissa, who are like a deep sea fan first, expert second, in our corner, who are willing and able to go out to sea and study these environments and bring us that cool footage and resources and answers. So in order to bring this topic into your classroom, I know we've hyped this up a lot. I'm handing the show over to Susan. She's going to tell us about some of those resources.
Thanks, Liz. Absolutely enjoyed the conversation. And I have to repeat what Belle said. What an inspiration. Melissa, you just do amazing work. And we're so excited to hear about your research and your expertise. As you all learned from Melissa and from Liz, the topic of cold seeps is really quite multidisciplinary. So you can teach geology, you can teach earth science, you can teach biology, chemistry, physical science, and even engineering based on how we get to explore these very distant environments. So if you're looking to dive a bit deeper into those topics and get cold seeps into your classroom, we've prepared a list of some of our favorite resources for you. So I'm going to share my screen, And you can see here, this is our list of Cold Seeps resources for educators. And you all have received this. And I'm going to just dance through this just a little bit to give you some of the background on what some of these items are. Here we've got lessons, we've got fact sheets, we've got multimedia, images and video, and a whole lot more to bring Cold Seeps alive in your classroom. And I want to highlight a couple of pieces that are hot off the press. Up here at the top in the lessons and activities section, we have 2 brand new student investigations or lessons, which our team developed in cooperation with our colleagues at the National Science Teaching Association. And these investigations challenge students to use the sense-making approach to better understand the unusual world of cold seeps. So I'm going to pop open the first one, which is a student investigation on fire ice in the deep sea. And this one focuses on phase change in these seep environments as it relates to methane gas hydrates. And students work to answer the question, how does methane hydrate form on and below the sea floor, which you all discussed, and you might remember this image of the methane ice from the conversation earlier. The second one that I wanted to pull up for you is a high school investigation, and this one focuses on our most recent understanding of how worms that live on methane ice actually feed. And these are small worms that live along and burrow into the sides of methane ice. And here the students work to answer the question, how do methane ice worms obtain organic compounds and energy while they're living on methane hydrates? And if you take a closer look at this page, where the lesson is, you'll see a link to a number of different resources that support the lesson. And you can also note here that these lessons support the next generation science standards. We identify performance expectations and disciplinary core ideas. And we also identify the ocean literacy essential principles and fundamental concepts that are supported with these specific lessons. And I also want to note that we have a number of different fact sheets that are a part of our resource list. We have one that's on cold seeps, one that's on cold seep communities, and one that is on chemosynthesis specifically. And I'm going to pull up the Cold Seeps communities one really quickly here on my screen. And I'm just going to scroll down to the second page of this. Oops, actually, I picked up the wrong one. I'm actually going to pull up the communities one. There we go. Communities, here we go. And if I scroll down, you'll see that ecological succession of seep sites image that Melissa and Liz were discussing earlier. So just so you know that that's offered right to you in a fact sheet with a hot link to it. And the other one I wanted to note is the chemosynthesis fact sheet. And Liz and Melissa spoke quite a bit about the differences and similarities between hydrothermal vents and cold seeps. And you can see here some illustrations that they were referencing of the chemical equations for chemosynthesis at vents and at seeps, and the sort of convoluted, complex transfer of energy. But this would be helpful for your classroom as well. And then I also want to point out to you that the link to the Deep Sea Dialogues video is here. It's about 10 minutes long, and just a note to share with you exactly where that is. I'm going to pop it up here, and this is the main page for our Deep Sea Dialogues resources. And I'm going to walk you through a little bit of our website, but at the top of all of our web pages, you'll see an education link. And within that drop-down menu, there's a section for multimedia educational resources. And that's where you can find all of our Deep Sea Dialogues videos, not just the one on cold seeps, but there are a number of other topics that we've covered over the past couple of years. So lots of great resources for your classroom. And with that, I'm going to shut a few things on my screen because I'm getting overwhelmed here with tabs. And also show you that at the bottom of your resource sheet, you'll see links to 2 different websites. If you're interested in diving a bit deeper, there's a lot of information on both the NOAA Ocean Exploration site and also the Deep Ocean Education Project site. So first, I'm going to take you to our NOAA Ocean Exploration site at oceanexplorer.noaa.gov and take you to the education page. And we're going to first see that there's a drop-down menu here, and we have all of our education information organized by themes. And you'll see that Cold Seeps is indeed one of the themes here. And if you click on the Cold Seeps link, you'll see that we've got sections on background information, lessons, multimedia, expeditions, and careers. And within that background information, you'll find those fact sheets that I just noted to you. And within the lessons section, you'll see those 2 lessons along with some other lessons that support Cold Seeps. So there's a lot going on in there. And if I go back up to the top to the education section, you'll also see under professional development that we have a section for educator opportunities. And there you're going to find the information about both our deep dives that you're experiencing tonight and also our professional development workshops, which I'll go into a little more detail in just a few moments. The other website that I wanted to highlight for you is the Deep Ocean Education Project website, which is a relatively new website. It was just launched in 2001. And this is a resource hub developed in collaboration with the National Marine Sanctuary Foundation. And it features educational resources from NOAA Ocean Exploration, from Ocean Exploration Trust, and also from Schmidt Ocean Institute. And I'm going to take you on a quick little tour. If we go to the Explore button here at the top, you'll see that it's organized by theme as well, similar to what you saw on the Ocean Exploration site. And you'll see much of the same topics, but you'll also see marine technology and you'll see ocean careers, because we know how important it is that you talk about ocean careers or careers in general in your classroom. And there's no shortage of ocean careers. Also wanted to note, if you scroll down from that just a bit, you can expand your search beyond each of these sections and search by topic, by resource type, and by organization. So if I search Cold Seeps and I go to resource type and I go to student activity, you can refine your search even farther and select by grade. So I'm going to select by grades 6 through 8. And you can see a couple of activities that are here, one of them being the Fire Ice in the Deep Sea lesson that I mentioned, and then one on modeling behavior using computer models and one on remote sensing, both from Ocean Exploration Trust. So lots and lots of great resources accessible on the Deep Ocean Education Project website. But one of the coolest things about it, the best feature that we like, is that you can create a free account to create your own collections. So I'm going to take you to my particular account up here at the very top right-hand corner. And this is the spot where you can sign up for your own account. And you'll see my list, my collection. So these are all the things that I've collected and different collections. So I have one on biodiversity, I have one on chemosynthesis, and I actually have one on Cold Seep resources. So these are all the items from the Deep Ocean Education Project website that I've put together in this section. And the great thing about it is I can share that collection with anybody that I want to. And you're actually going to receive this collection later this week because we have your email list. And then hopefully you'll share bits and pieces of this that you find important with your colleagues. And also, if you're excited about this website, we will be going through it in a bit more detail and helping people create their own collections during our educator professional development that we're doing over the next several weeks. And one of the last things that I want to share with you within the Deep Ocean Education Project site is this vessels link that's up here at the top. And Liz mentioned this a little bit earlier. As we mentioned, this is a cooperative website between NOAA Ocean Exploration Trust, and Schmidt Ocean Institute. So we have the Okeanos Explorer, we have the Nautilus, and we have Falkor 2 highlighted here. And you can see where they are in the map at any given time. And you can see if they are live or not. And right now, as Liz mentioned, the Falkor 2 is exploring the Mid-Atlantic Ridge, and they are live. So you can go straight to their website from the Deep Ocean Education Project and see what's going on right there, right now. So I encourage you all to do that when you have a few moments, and keep an eye on that website and keep an eye on the vessels and where they're going. You can also look down below where the ships are identified here to see what's coming up, so you can be prepared for expeditions that are coming down the road. So we're excited to have you check out all of those resources in a little more detail. I'm going to pause here for a moment because I'd like to do a little bit of wrap up with you before we talk to you about our professional development and give you some insight to the wheres and whens of that. We'd love to do a word cloud with you all and hear what you enjoyed most about this evening's event. So you've got another QR code here and a menti.com code. If you could take a moment to tap into that and drop a couple of words into the word cloud to let us know what you loved most about this evening, what you found most intriguing, and we'll pull that back up in just a few moments. And while you're doing that, I just want to share one last bit of information with you. I'm going to go back to our educator opportunities page. And again, you get there from education at the top to professional development to educator opportunities. And down here at the bottom, you'll see that we are offering these Cold Seep professional development workshops, both virtually and on site at some of our Education Alliance partners. And I'm going to pull up the available spots. The opportunity is called Mysteries of Fire Ice, Cold Seeps, and Chemosynthetic Communities. And there's a little description of what this opportunity will be all about. Our virtual opportunities are 90 minutes long and are offered at the sites that you see listed here. And our on-site opportunities are about 4 hours, and they'll be in person at the sites that you see listed here on the right. And if you try to sign up and either the virtual or the on-site near you or that you're interested in is full, feel free to register for a different virtual site that might still have space. So we hope to see you at one of those professional development opportunities. And with that, I'm going to turn it back over to Liz.
Thanks to everyone, and thanks so much, Susan. I want to wrap us up first with a big thank you to Melissa once again for her time and for sharing her expertise with us. And I know we've got a lot of those thank yous rolling in throughout. Again, if you have any burning questions that we didn't answer, please feel free to send them to our email. Our education team email is oceanexeducation@noaa.gov. We'll see if we can get that banner up along the bottom too. But one more time, that's oceanexeducation@noaa.gov. And again, if you're attending any of our events or a question comes up throughout, please don't hesitate to reach out to us. Or you can also bring those questions with you if you register for one of our following professional development events that Susan just shared. I see as things are rolling in, our word cloud is growing. So let's see if we can get that a little bit bigger on your screen so we can share some of the fun. I love the chemosynthesis was the one that I could read while it was still tiny. A really exciting topic, personally, one of my favorite. Opportunity to ask an expert. Oh, so great. Yes. Phenomenon based. Opportunities to say yes. Yeah, I love that we end on such a positive message. Resources. Yeti crabs, absolutely. And fascinating. And I like that that's equal with chemosynthesis because it's exactly how I would describe it. Awesome. Well, we'll be sure to share out those resources again after tonight's event, and that collection that Susan showed, we can share with all of you who registered for the event. If you're joining us on Facebook and you didn't register and we don't have your email, please do also send your email if you'd like for our future newsletter or more resources to that email that we shared. Again, that's oceanexeducation@noaa.gov. And before we completely wrap up for the evening, I can't not say thank you to all of our team. So you only saw Susan, Melissa, and I in front of the screen, but it takes a village to run these programs. And so really want to give a special shout out and thank you to our NOAA Ocean Exploration team that helped with this, as well as the National Marine Sanctuary Foundation, and of course, the University of Rhode Island's Inner Space Center. Thank you all for all of your great responses as well. Your participation really keeps these events going. It's wonderful to see all of the enthusiasm you bring. And this brings us to the conclusion of our evening. So again, thank you for participating, and we hope you consider ways to bring this topic into your classroom or your teaching for those of you informal educators joining. And again, sign up for those PDs. We'll dive deeper into those lessons and resources and demonstrate some of those activities as well. So thanks again for joining, and don't hesitate to reach out.